Colleton here, and I'm here to demonstrate how to do the water wheel kinetic to potential energy activity that you guys will be doing. So first I'm going to show you what it's going to look like, and then I'll give you some tips and tricks about how to make it work the best. So I'm here by my kitchen sink because that's the sink I'm working with. I have my water bottle with all of my little pieces on it. This is one I threw together, made out of some packing materials that one of my orders had come in. I have a dowel through my water bottle. On one side of my water bottle, I have my string with 3 quarters taped together on it. And then you can't see it, but you'll have to trust me that it's there. I have a measuring tape that is taped from here at the top of my counter all the way down to the ground, and it's on the centimeter side because that's what we use in science, is the metric system. So what I'm going to do is I'm going to drop my quarters down towards the ground where the measuring tape is, and I'm going to be holding my water bottle underneath my sink. I'm actually going to hold it this way, so it's a little bit easier for me. So then what I have to do, and or a sibling to help you out with, is I need to mark or note down my starting point. That's where my quarters are starting. So holding this exactly where you're going to have it for when you have the water on. Have someone look down and say, oh, it's at, for Miss Colleton, it's at 75 centimeters from the top of the counter. And then write that down in your data table. So then what you're going to do is you're going to turn on the water. You can turn it on as light of a flow or as heavy of a flow as you want. You're going to run the water for about 60 seconds. So let's do that now. So mine has reached a stopping point. Doesn't look like it's going to go any farther. So I'm going to stop there. So then what I would do is I would look at where my quarters are right now. So don't let the quarters drop from your stopping point, but go ahead and look. And so it looks like my quarters are at 50 centimeters. So I'd find the difference between them, and then that is the change in height of my quarters. Now for some tips and tricks. One thing that we had a lot of problem with when we did this in the classroom is as these were spinning, if this string starts wrapping around the dowel, this spin here will stop. And that's not what we want. So you need to be really careful. If that does happen to you, just unwind it and then start again. The second thing that could happen, and one other way to fix that is to let it tilt a little bit as you're running it. If you tilt it away from where you tied the string, then that typically helps with that wrapping around the dowel. Now, when it comes to poking this hole here at the bottom of your water bottle, a couple tips. It'll be easier if you keep the cap of your plastic bottle on. So that does help. My #1 recommended way of poking the hole in the bottom of a plastic bottle is to actually use a drill. So find a drill bit if you have one that's slightly bigger than the dowel that you're going to be using, and then go ahead and drill a hole in the bottom. A hammer and nail also works pretty well. And then you can also use scissors or maybe the tip of a sharp knife if you're very careful, or ask an adult to help you. So that's the water wheel activity. We're going to use that to show how kinetic energy that's going into your wheel is going to change the potential energy of these quarters. So good luck, and of course email myself or Miss Van Moore if you're Miss Van Moore's student if you're having any problems or you have any questions. Good luck.